unit of time on a server, right? It's 1 gigahertz, 2 gigahertz. If you're going to spend some more of your cycles on encryption, it means you have fewer cycles available for more users. So if you previously supported 100 users, now you might support only fewer than 100 users. Is that reason enough to make all of your users vulnerable to this? No, probably not. And to be honest, in the commercial world, there exist devices that called SSL offloaders that you do all the encryption for you, so you don't have to worry about pinching pennies in that way. You just have to buy 1 or 2 such devices. So this is something, too, that frankly, moving forward, all of your sites should operate over SSL. I mean, even the courses, CS50s, all of our stuff, almost all of our stuff now is over SSL because it's so easy to do. And frankly, not until you get to the point of like Facebook and Google and Twitter where you really have to worry about saving every little CPU cycle is this probably a financial issue anyway. All right, what about this other set cookie? This suggests a vulnerability or a poor design decision. What has this developer apparently done? How can you remember that a user has logged in to a website? Poorly, let's say. So you can just plant whatever they typed into the password field in a cookie and just ensure that every time the browser revisits the page, here's my password, here's my password. Is this such a big deal over SSL? You know, maybe not, but is it necessary? Probably not. You should generally minimize the number of times anything important goes across the wire, and of course the session ID should obviate the need for that, because that's the number that should be remembering that some user is logged in. Yeah?
So, quick question about encryption. So, I know that the way you talk about it, so we should trust across the board. Are there any vulnerabilities to websites that claim to use SSL without using it properly? Like they don't do the certificates right, or they're getting spoofed in that way. Is there anything we should look out for?
Oh, good question. So things to look out for even when using SSL. So actually, let's come back to that in just a moment and then dive in deeper with the crypto itself. And for now, let's just finish up this one thread with session hijacking. So this is the Firesheep stuff for those familiar with that particular tool. So how do you go about stealing someone's session? Well, you download Wireshark for free, you turn your computer into promiscuous mode, and voila, you have all of the HTTP traffic flowing locally around you, and you can just cherry pick all of the session IDs you want. Or even easier, you download something like Firesheep, which does all that work for you and just gives you a list of Facebook faces to double click on to log into that person's account. But what about physical access? If anyone ever has physical access to your computer, you're kind of screwed. Like whether it's a Mac, PC, server, or whatnot, because even Linux servers, for instance, which might have root access and separate user accounts and the like, as soon as you walk up to a physical machine, you can generally either reboot it and then type a command into what are called the kernel parameters. For instance, in Linux, if you play with the appliance and you hit escape at the right time, and then you hit E for edit, and then E for edit again, and you type in the word S or single for single user mode on a Linux server, that gives you unrestricted access to the entire system, loading to the blinking prompt without even asking you for the root password. And that simply requires physical access. On some servers, you might think, oh, but I'm super paranoid. My PC in particular has a BIOS password, so you can't even boot the computer without a password. Yeah, well, if I look up the user manual and I figure out what jumper I need to touch inside your motherboard, I can remove the lid of your computer. I can take a tiny little piece of plastic and metal, make it close a circuit between 2 little metal pins, and that will typically wipe out whatever BIOS password you have. Now, why is that useful? Well, there's a lot of humans that forget their BIOS passwords, so that's the way to reset them. But if an adversary knows this, again, you're kind of screwed. So physical access, bad. But also, of course, hard to prevent against. Yeah.
And encrypting your entire computer wouldn't do anything either?
Encrypting your entire computer. So that's definitely compelling to encrypt your computer, but when you're using it, the information obviously has to be decrypted. So right now, for instance, if you are using File Vault on a Mac and even secure virtual memory, so long as your lid doesn't close and the password's not forgotten, now I could access anything on the computer, but using full disk encryption, absolutely good. And in fact, as an aside, unrelated to websites and such, if you have a Mac in this room, go find the option sometime tonight or soon and turn on full disk encryption. And if you're really paranoid, secure virtual memory, which also encrypts your use of RAM, so that if your laptop is ever lost or stolen, it's at least the hardware that's gone and not sensitive information you don't want someone else to see. PCs, frankly, Microsoft has never made this easy. You have to generally buy some third-party product to do this. Yeah?
Are there any performance drawbacks to that?
Yes. Are there performance drawbacks? Yes. None of this stuff comes for free. You have the crypto involved, but frankly, on machines these days, it's probably a price worth paying unless you truly have nothing that you care about on the computer.
Can you repeat those two options for the Mac?
Sure. The Google File Vault, one word. And then Google Secure Virtual Memory. And I think there, if you go to System Preferences and go to Security, you can do it there. But two caveats. One, don't do it in class, because if you close your lid, bad things happen. If you lose power, bad things happen. And I would generally back up before, just because when you're encrypting your entire hard drive, if something does go wrong, you will just be left with a sequence of random bits. But this has its advantages. Those of you who have iOS devices, if you've ever wiped the device, if you had iOS 3, and I don't think 4, but iOS 3, it would actually take a long time to wipe the device, because all of the bits would be overwritten with zeros and ones and the like. And that was a good thing if you wanted to sell the phone or give it back to the Apple Store, and you didn't want anyone getting your emails or any sensitive information that was on there. But now you can wipe an iPhone or an iPad actually within seconds or maybe a minute, much, much faster, even though the device might be 64 gigs. How do you do that? How do you still wipe a device effectively, but do it much quicker than apparently they previously did?
You just wipe the hashing login to decrypt everything?
Yeah, so you wipe the key that's being used. So if you keep the entire device encrypted all the time, which does have a computational cost and might slow things down some percent, well, if you want to wipe the device, all you have to do is overwrite with zeros and ones just the key that's being used to encrypt the entire device, like the password that you typed in to unlock the device, because as soon as you lose that key, by nature of encryption, if it's a good encryption algorithm, all of your data will appear already to be random. It's not going to be all zeros, but it will at least be a random sequence of zeros and ones if the cipher is in fact probabilistically good. So that's a good thing. Crypto is actually quite cool. And if interested in this kind of stuff, CS 221, generally taught by Michael Rabin, Turing Award winner, is a fascinating class to take on the subject. RJ.
So if you do this file vault thing and you encrypt your hard drive, and then an OS file gets broken in some way, is there a way to get back to your data, or are you kind of screwed with that one?
Good question. If your data is encrypted and something goes wrong, the bar has been raised to getting it back, yes, in fairness. So in this case, backups are good. And even now, Time Machine, which comes with Mac OS, can support backups that have been encrypted with File Vault. So there, the best solution is backups. And sorry this is so biased toward Macs. It's just Apple has done an amazing job at making this easy, and Windows, for some reason, has never made it as simple as a menu option. Maybe that'll change in the next version. All right. So if you're doing sketchy things, get a Mac, I guess is the takeaway here. All right. So other things you can defend against. So physical access, you can only do so much sometimes. How about packet sniffing? So how do we actually prevent someone like me from doing what I was doing with Wireshark there? How do you actually hedge against this risk? Because if you're in an airport, you're in Harvard. I mean, Harvard's access points are all over campus. We could certainly sniff a whole lot of data. Don't. What could you do, though, to defend yourself against that kind of attack and the stealing of your cookies and the like? Yeah, so you could use a VPN. And even though this might seem a little silly, you could be on Harvard's network, VPN to vpn.fas.harvard.edu, so that at least you're protecting yourself against all the random people near you wirelessly, and now only exposing yourself to risk by people who have physical access to the network, which are more likely to be sysadmins, people in the physical science center, or still random people on the internet, certainly. But odds are you might be more concerned, just by nature of the threat, you're concerned about your roommate or people who actually know or care what you're actually saying on an email or an instant message, whereas everyone on the internet probably doesn't care too much about what you're doing. So vpn.fas.harvard.edu is something you can all sign into, and it's actually good if you're on in an airport, in Starbucks, or in another country that doesn't let you access certain sites. You can pretend to be on Harvard's campus that way. Other tricks? Yeah?
If you're really crazy, you can use Tor.
Okay, so Tor. What is Tor?
Tor, I think it was developed by the Navy, but the idea is that there are different nodes that exist all across the world.
Mm-hmm.
And so when you send information, it sends it to a random node somewhere else in the world. So unless you somehow did statistical analysis of the entire internet, you really can't figure out which packet was sent where by what computer.
Good. Yeah. So Tor, to summarize, is a distributed proxying service, and it's a system sort of like a peer-to-peer network. So random people can download the Tor client, run it on their computer, and then they become a Tor node. And it's used in exactly that way. If you want to do something privately or statistically securely, you can use the Tor network so that your data, much like in the movies, frankly, is routed from here to here to here to here to here to here to here, finally to the endpoint, because it's then much harder for people to actually figure out what your origin is, because the data is going to be coming from some random person's computer here, and even if they go look at that computer or subpoena that human, then they have to trace it back one step to the previous computer, to the previous computer, to the previous computer. So it's actually a relatively effective technique for anonymizing your traffic. Of course, you have to trust all of these middlemen, and there's nothing stopping the government from being one of the Tor nodes and being one of the partners in this relationship, but at least it's a mechanism. It does tend to slow things down, though. Other tricks that one can employ? At least at home, you can use something like encrypted access points. And Harvard doesn't do this, probably either for performance or just convenience. MIT, though, has a secure version of their network. Other universities do as well. The only gotcha there is that you can have a WPA2, or WEP is bad, WPA2 encrypted network. But what's the gotcha? Because it's not obvious that Harvard's doing anything wrong here. Because if we do use encrypted Wi-Fi, what's the implication for users? If we want all of you to still be able to connect to the encrypted Wi-Fi, we have to tell like 30,000 Harvard affiliates what the password actually is, so that's not necessarily raising the bar all that much. I mean, some schools actually just post it on their website so that you at least have to know what you're looking for, but there are enterprise solutions as well. But it just gets harder to do that. So thankfully, clients do this end to end. And we'll come back to this last one, XSS, in just a moment. So quick look at SSL. SSL is all about HTTPS and about encrypting things end to end. What does it involve if you want to start your newcompany.com and you want to run everything over SSL? How do you make that happen? What's step one? Yeah.
You've got to purchase a certificate from a trusted authority.
Good. So you have to purchase a certificate from a trusted authority. You can do this from a whole bunch of places. One of the places that's relatively cheap, though there are even cheaper places, is GoDaddy here. For instance, if we go to SSL and security, and we scroll down here, you'll see that you can get standard SSL for $69 a year or premium SSL for $99. What's the difference, as best you can tell?
It's a green box around that one.
Yeah, so you get this green box. So that's literally it. So for $30 more, you get a green box around your URL. And this is because the browsers, there's some merit to this idea. Some browsers decided that at least to raise the bar so as to make it more obvious to users that this is a legitimate encrypted connection to a legitimate website, you can pay a bit more. And certain browsers, like Firefox, for instance, will turn the URL a different color, signifying really that these people paid more and also that we, in theory, vetted them more. So you didn't just automatically get an SSL certificate after giving a credit card number, which might be stolen. They do a bit more due diligence and try to figure out if the person ordering the certificate is who he or she claims to be. Crypto-wise, what more do you get? Well, apparently you get like $250,000 warranty with $99 versus only $10,000 warranty. Now, if you ever read the fine print, this is kind of meaningless, right? This probably says something like if the RSA algorithm is cracked, like we will give you this much money versus this much money, which is not likely to happen. And even if it did, they're not likely to pay out, certainly given how many customers they have. So in short, paying for more expensive certificates, generally kind of dumb and unnecessary, at least for websites that aren't banks and don't really have the money to just throw on at things like this. I mean, out of curiosity, how many of you knew before a minute ago that green meant something more? So 1, 2, 3, okay, so like 7 or 8 people. Okay, so the $30 is to make those 7 or 8 people happy. And of those 7 or 8 people, how many of you would not visit a website whose URL is in green? Right, so I mean, what's the point, really? So nice idea, but hasn't quite gotten popularized. Now, if you want real security, you can go with a brand name like verisign.com. And if we go to VeriSign and I go to SSL certificates, which a lot of companies do, get redirected here. And then let's see. Oh, you know it's going to be cheap when they don't even show you the prices. So let's see. This green looks good. So let's go. This is Secure Site Pro with EV, extended validation, whatever that is. $1.5 million warranty. That sounds amazing. So let's go here. All right. How many years? We'll just do 1 year, 1 certificate, organizations. Okay, don't need another name, don't need them to contact me. Ooh, there it is. $1,400. Not bad for the same exact math that we could have gotten from GoDaddy, and you can get it even cheaper at other places as well. And technically, you can generate certificates yourself. And that's actually the only bad option, at least for corporate websites. So what's really going on here? So how does SSL work? Well, if you're generally familiar with public key cryptography, there's two keys involved in this encryption process. The browser has a public and a private key, and the server has a public key and a private key. And thanks to very nice math, and we'll take a look at a representative example called Diffie-Hellman in a bit, thanks to very clever math, Alice can ask Bob for his public key. Alice can then encrypt information